Welcome back, everyone, to the deep dive. Today, we're going deep into neuro-symbolic AI.
Yeah, it's a fascinating area.
It is. I think it'll be really, really fascinating for our listeners to kind of get a better grasp on how these two worlds are colliding.
Absolutely.
The symbolic world and the connectionist world, right?
Right.
And so for our listeners who are already, pretty well versed in AI, we're going to try to keep this high level, but also we're going to go deep.
Yeah.
We're going to go really deep.
Look, a deep dive.
We're going to deep dive. That's right. So, if you're not familiar with AI, that's totally fine. We're going to do our best to explain everything in a way that's easy to understand.
Yeah, and if you are familiar with AI, I think there's still going to be a lot of really interesting nuances and insights that we can kind of tease out from this conversation.
Yeah, and I think, the goal here is really to understand, what is neuro-symbolic AI? Right. What are the key ideas? Why is it so important? And, what's the potential impact?
Yeah, and I think, just starting out, when we think about the history of AI research, there have been these two kind of dominant paradigms.
Yeah.
And so we have, symbolic AI, which really was kind of like the original or the earlier approach to AI, which really focused on using rules and logic to represent knowledge and to manipulate it.
Right.
And so expert systems are a really good example of that, where you have, knowledge that's been explicitly encoded by experts in a particular domain.
Yeah.
And then you have a reasoning engine that uses those rules to kind of make decisions or to answer questions. Then you have, connectionist models. And this has really been, where a lot of the progress in AI has been made in the last, 10 or 20 years. And that's really based on the idea of using neural networks, which are these kind of systems that are inspired by the brain that are able to learn from data and to identify patterns and to make predictions.
Yeah, and so deep learning is a subset of connectionist models.
Exactly.
Yeah. Where, you have these multi-layered neural networks that are just really, really good at, identifying patterns, particularly in unstructured data, right? So think about images, audio, text. And that's been really driving a lot of the progress in areas like, image recognition, speech recognition, natural language processing, things like that.
Yeah. And I think what's interesting is that, now we're kind of seeing this kind of convergence, right? This kind of coming together of these two paradigms with neuro-symbolic AI.
Synergy, sir.
Exactly. Right. And I think the real kind of driving force behind this is this recognition that both of these approaches have their strengths and weaknesses.
Right.
And that by combining them, we can potentially create AI systems that are much more powerful, much more robust, much more generalizable, and much more trustworthy.
Yeah, and I think, a lot of people believe that this is really a crucial step towards achieving AGI, right?
Yeah.
Artificial general intelligence.
That is
So, this idea of having AI that can actually think and reason like a human.
Yeah, and one of the big motivations for this, I think, is that if we look at the human brain, right, we don't just have one kind of thinking.
Yeah.
We have both this ability to kind of intuitively learn from data, but we also have this ability to reason logically and to use abstract concepts.
Right.
And so the idea is that by combining these two types of thinking in AI systems, we can get closer to that kind of general intelligence that we see in humans.
Yeah. So I think it would be helpful for our listeners to kind of dive a little bit deeper into, these two paradigms.
Absolutely.
Let's start with deep learning.
Sure.
Since it's been so dominant in the last, few years, what exactly is it about deep learning that makes it so powerful? What are those key strengths that have allowed it to achieve these really impressive results?
Yeah, so I think one of the key strengths of deep learning is its ability to learn these really complex patterns from data.
Right.
And, as we were talking about before, these neural networks are able to process information through these multiple layers.
Yeah.
And each layer is able to extract increasingly more complex features from the data.
Yeah, it's kind of like, if you think about the human visual system.
Yeah, right.
You have these different layers of processing from the retina all the way up to the visual cortex.
Yeah.
And each layer is kind of extracting more and more complex information from the previous layer.
Yeah. And so, in the case of, let's say, an image recognition system, the first layer might be detecting, very simple features like edges or lines.
Right.
And then the next layer might be detecting combinations of those features. So corners or curves.
Right.
And the next layer might be detecting even more complex features like shapes or objects.
Right.
And so by the time you get to the final layer of the network, it's able to recognize very complex patterns
Yeah.
and to make very accurate predictions about what's in the image.
Yeah, and one of the things that's really amazing about deep learning is that it can work with these vast amounts of unstructured data.
Right.
So like, images, audio, text, where traditional programming methods would really struggle.
Yeah, and I think that's really been one of the key drivers of the progress in deep learning
Mm.
is this availability of these massive data sets.
Right.
And the fact that we now have the computational power to actually train these models on these data sets.
Yeah, so we have more data and we have the compute power to actually do something with that data.
Exactly.
Right.
Yeah.
And so that's really been a big game changer.
Yeah, and I think, in addition to just the ability to learn from data, deep learning also has this really nice property of being able to generalize to new data.
All right.
So, once you've trained a deep learning model on a particular data set, it can often perform very well on new data that it's never seen before.
And we also have, these different types of neural networks that are specialized for different tasks.
Right.
So, for example, we have CNNs, right? Convolutional neural networks, which are really good at processing images.
Yeah.
And then we have RNNs, recurrent neural networks, and transformers, which are really good at processing sequences of data, like text or audio.
Yeah, and I think that's been another key factor in the success of deep learning is that researchers have been able to develop these very specialized architectures
Right.
that are really well suited for particular types of tasks.
Yeah, I mean, it's just incredible, like, how well these things work, right?
Uh-huh.
Like, facial recognition, speech to text, all these things that were, like, science fiction a few years ago.
Right.
Now they're just, like, commonplace.
Yeah, exactly. And I think, we're just kind of at the beginning of seeing what's possible with deep learning.
Right.
There's so much more research that's being done, and I think we're going to see even more amazing applications in years to come.
But, as amazing as it is, it's not a silver bullet, right? And this is, like, the big challenge that we're talking about today.
Yeah.
Right? There's this, like, inherent limitation with deep learning, which is this black box problem.
Yeah, that's one of the major criticisms, I think, of deep learning is that, it can be very difficult to understand why these models are making the decisions that they're making.
Right. Like you can train a deep learning model to, identify cats in images.
Right.
And it'll do it with 99% accuracy. But if you ask it, okay, how do you know that this is a cat? It can't really tell you.
Yeah.
Right? It's just like, oh, I don't know, just no.
Right. It's just kind of like this black box that takes in some input and produces some output.
Right.
And we don't really have a good understanding of what's going on inside that box.
Yeah. And so that can be really problematic, especially in areas where, explainability is really important, like healthcare, finance, where you need to be able to understand why the AI is making the decisions that it's making.
Yeah. And I think another limitation of deep learning is that it can be very data hungry.
Right.
So, to train these models to achieve these really high levels of performance, you typically need very large amounts of data.
Yeah.
And that data can be very expensive to collect, and it can also be very difficult to label.
Right. And it can also perpetuate biases, right?
Absolutely.
If the data that you're training on is biased, then the model that you're training is going to be biased as well.
Yeah. So I think, while the deep learning has been incredibly successful, it's important to recognize that it does have these limitations.
Right.
And that's one of the reasons why there's so much interest in Neuro-Symbolic AI, which is this idea of combining deep learning with symbolic reasoning.
Right. Okay. So let's talk about symbolic reasoning.
Yeah.
This is like, the other side of the coin.
Right.
Right. So in contrast to deep learning, which is all about learning from data, symbolic reasoning is about using symbols and logic to represent knowledge.
Exactly.
Right. And so this approach has been around for a long time.
Yeah, it's kind of like the classical AI approach.
Right.
Going back to the early days of AI research.
Yeah. And so the basic idea is that you can represent knowledge using symbols, which could be, words, numbers, logical operators, things like that.
Right.
And then you can manipulate these symbols using rules of logic to derive new knowledge or to make inferences.
Yeah, and I think one of the key advantages of symbolic reasoning is that it's very transparent.
Right.
So, you can look at the rules that are being used to make inferences, and you can understand exactly how the system is arriving at its conclusions.
Right. Like, if you have a rule that says all men are mortal, Socrates is a man, therefore Socrates is mortal,
Right.
you can, like, follow the logic there, and you can see exactly how the system arrived at the conclusion that Socrates is mortal.
Yeah, exactly. And so that makes symbolic reasoning very well suited for applications where explainability is important.
Right.
Like in the medical domain, for example.
Yeah, where you need to be able to understand, like, why the AI is recommending a particular treatment.
Exactly.
Right.
Yeah.
And so, symbolic reasoning has also been used in other areas like, planning, scheduling, expert systems, things like that.
Yeah, and I think, another advantage of symbolic reasoning is that it can be very efficient.
Right. Yeah.
So, once you've encoded the knowledge into the system, it can often make inferences very quickly.
Right.
And that can be important in applications where real-time performance is required.
Yeah. But, just like deep learning, symbolic reasoning also has its limitations, right?
Yes.
So what are those?
Yeah. So I think one of the biggest limitations of symbolic reasoning is that it can be very difficult to encode knowledge into the system in the first place.
Right.
The world is a very complex place, and it's very difficult to capture all of that complexity using symbols and rules.
Right. And you have to do it manually, right?
Exactly.
Like, you have to sit down and, like, write out all the rules and all the symbols and, like, it's a very time-consuming and labor-intensive process.
Yeah, and it can also be very brittle.
Right.
So if you make even a small mistake in encoding the knowledge, it can lead to very big errors in the system's output.
Yeah, and so that's one of the reasons why symbolic reasoning has kind of fallen out of favor in recent years.
Right.
Right? As deep learning has become more popular.
Yeah, but I think, there's still a lot of potential in symbolic reasoning.
Yeah.
And I think we're going to see a resurgence of interest in it in the years to come, particularly as we start to look at combining it with deep learning.
Right. Okay, so now we're getting to the heart of the matter, right?
Right.
Neuro-Symbolic AI.
Yeah.
So, we've talked about deep learning, we've talked about symbolic reasoning, and now we're talking about this idea of combining these two approaches.
Right.
Right. So what are the key motivations for this integration? Like, why are researchers so excited about this?
Yeah. So I think there are a number of reasons why researchers are excited about neuro-symbolic AI. One reason is that it has the potential to overcome the limitations of both deep learning and symbolic reasoning.
Right.
So, as we've been discussing, deep learning is very good at learning from data, but it can be difficult to understand why it's making the decisions that it's making.
Right.
And symbolic reasoning is very transparent, but it can be difficult to encode knowledge into the system.
Right.
So the hope is that by combining these two approaches, we can create AI systems that are both powerful and interpretable.
Yeah. And so, another motivation is that it has the potential to create more robust and generalizable AI systems.
Right.
Right. So deep learning systems are often very brittle, meaning that they can perform very poorly on data that's even slightly different from the data that they were trained on.
Yeah.
And symbolic reasoning systems can be very inflexible, meaning that they can have difficulty adapting to new situations.
Right.
So the hope is that by combining these two approaches, we can create AI systems that are more robust to changes in the data and that can generalize better to new situations.
Yeah. And I think, in another motivation is that it has the potential to create AI systems that are more capable of higher level reasoning.
Right.
So, deep learning systems are very good at, recognizing patterns and making predictions, but are not very good at reasoning about those patterns or making plans based on those predictions.
Right.
And symbolic reasoning systems are very good at reasoning, but they can have difficulty with the perceptual tasks that deep learning systems are so good at.
Right.
So the hope is that by combining these two approaches, we can create AI systems that can both perceive the world and reason about it.
Right. And so, one of the things that's really exciting about neuro-symbolic AI is that it's not just about, taking a deep learning system and slapping a symbolic reasoning system on top of it.
Right.
Right. It's about creating a true synergy between these two approaches.
Yeah, it's about finding ways for these two systems to communicate with each other.
Right.
And to complement each other's strengths.
Yeah, I think that's a really important point because, a lot of times when people talk about AI, they talk about it as if it's like, one thing.
Right.
Right. But it's not. It's like this whole spectrum of different approaches.
Exactly.
And so neuro-symbolic AI is really about bringing together the best of both worlds.
Yeah, and I think, one of the challenges in neuro-symbolic AI is that it's not always clear how to do that.
Right.
These two approaches are very different, and they operate on very different types of data.
Yeah, it's like trying to get like, oil and water to mix.
Right.
Right.
Yeah.
And so, researchers are still trying to figure out the best ways to integrate these two approaches.
Yeah. But I think we're starting to see some really promising results.
Yeah. Okay. So let's talk about some of the specific techniques and tools that are being used in neurosymbolic AI. We've talked about this in a very high level way so far, but let's get a little bit more concrete.
Absolutely.
Right. So what are some of the things that researchers are actually doing to integrate these two approaches?
Yeah. So I think one of the key challenges in neuro-symbolic AI is this problem of symbol grounding.
Right.
In symbolic reasoning, we use symbols to represent concepts,
Right.
but those symbols are just abstract representations.
Yeah.
And so the question is, how do we connect those symbols to the real world?
Right.
How do we make sure that the symbol cat actually refers to a cat in the real world?
Yeah, that's a really good point.
And so there are a number of different approaches to symbol grounding. One approach is to use deep learning to learn embeddings for symbols.
Right.
And so an embedding is just a numerical representation of a symbol.
Right.
And so by learning embeddings for symbols, we can start to capture some of the semantic relationships between those symbols. And that can help us to connect those symbols to the real world.
Yeah, so it's like, if you have a word embedding for the word cat,
Right.
it might be like, a vector of numbers that
Oh, yeah,
captures like, all the different things that we associate with the concept of a cat.
Exactly.
Right, like, it's furry, it has 4 legs, it meows, it chases mice, all that stuff.
Yeah. And so, once we have these embeddings for symbols, we can start to use them in deep learning models.
Right.
And so that allows us to start to integrate symbolic reasoning into deep learning.
Yeah, that's really cool.
Another technique that's being used in neurosymbolic AI is knowledge graph embedding.
Right.
And so a knowledge graph is just a graph that represents knowledge in the form of entities and relationships between those entities.
Right.
And so, for example, you might have a knowledge graph that represents information about movies.
Right.
And so you might have entities for movies, actors, directors, genres, things like that. And then you might have relationships between those entities. So like, this actor starred in this movie, this director directed this movie's in this genre, things like that.
Right.
And so knowledge graph embedding is just a way of learning embeddings for the entities and relationships in a knowledge graph.
Right.
And so once we have those embeddings, we can start to use them in deep learning models.
Right.
And so that allows us to start to integrate knowledge graphs into deep learning.
Yeah, and so, knowledge graphs are really powerful because they allow us to represent knowledge in a very structured way.
Right.
Right. And so that makes it easier for AI systems to reason about that knowledge.
Exactly.
Right.
Yeah.
And so, knowledge graph embedding is a really promising technique for integrating symbolic reasoning into deep learning.
And I think, another technique that's worth mentioning is neural program induction.
Right.
And so this is a technique where we try to train deep learning models to actually generate programs. And so the idea is that, if we can train deep learning models to generate programs, then those programs can be used to perform symbolic reasoning.
Right.
And so this is still a very early stage of research.
Right.
But I think it has a lot of potential.
Yeah, I mean, it's like, the holy grail of AI in some ways, right?
Right.
Like if we can get AI to actually write its own programs,
Yeah.
right, then the sky's the limit.
Yeah, exactly.
Right.
And then another area that's worth mentioning is neuro-symbolic concept learning.
Right.
And so this is really about trying to combine the strengths of deep learning and symbolic reasoning to create AI systems that can learn new concepts more effectively.
Right.
And so, one of the challenges in AI is that, it can be very difficult for AI systems to learn new concepts from just a few examples.
Right. Like humans are really good at that.
Exactly.
Right. Like, if you show a child a picture of a cat,
Right.
they can pretty much immediately recognize other cats, even if they look different. Right.
Yeah.
But AI systems typically need to see a lot of examples of a concept before they can start to learn it.
Yeah. And so the idea with neurosymbolic concept learning is that we can use symbolic reasoning to help AI systems learn new concepts more quickly.
Right.
So, for example, we might use symbolic reasoning to define a concept in terms of its essential features.
Right.
And then we can use deep learning to learn how to recognize those features in the real world.
Right.
And so that allows us to create AI systems that can learn new concepts from just a few examples.
Yeah, that's really cool.
And then, another technique that's being used in Neuro-Symbolic AI is logic tensor networks.
Right.
And so these are essentially neural networks that are designed to operate on logical statements.
Right.
And so this allows us to use deep learning to learn logical rules.
Right.
And that can be very powerful because it allows us to combine the power of deep learning with the transparency of symbolic reasoning.
Yeah, I think that's a really important point.
Yeah.
Because, one of the big challenges with deep learning is that it's often very difficult to understand why it's making the decisions that it's making, right? But if we can use deep learning to learn logical rules,
Right.
then we can actually, see the rules that it's using to make its decisions.
Exactly.
Right. And so that makes it a lot more transparent and a lot more explainable.
Yeah. And I think, in addition to these techniques, there are also a number of different frameworks and platforms that are being developed for Neuro-Symbolic AI.
Right.
So, for example, there are frameworks like explainable neural networks, XNNs,
Right.
which are designed to make deep learning models more interpretable.
Right.
And there are platforms like Scallop and DeepProblog, which are designed to make it easier to integrate symbolic reasoning into deep learning.
Right. So it's like this whole ecosystem of tools and techniques that are being developed to make Neuro-Symbolic AI more accessible and more powerful.
Exactly.
Yeah. Okay, so let's talk about the benefits of Neuro-Symbolic AI.
Sure.
We've talked about some of the motivations and some of the techniques, but what are the actual benefits that we can expect to see from this approach?
Yeah, so I think there are a number of potential benefits of Neuro-Symbolic AI. One benefit is that it has the potential to create more interpretable AI systems.
Right.
Um, so, as we've been discussing, deep learning systems can be very difficult to interpret.
Right.
But by combining deep learning with symbolic reasoning, we can create AI systems that can provide explanations for their decisions.
Right.
And that can be very important in applications where trust and accountability are important.
Right. Like, if you're using an AI system to make decisions about healthcare or finance,
Exactly.
you need to be able to understand why the AI is making the decisions that it's making.
Yeah, and I think another benefit of Neuro-Symbolic AI is that it has the potential to create more robust and generalizable AI systems. So, as we've been discussing, deep learning systems can be very brittle.
Right.
But by combining deep learning with symbolic reasoning, we can create AI systems that are more robust to changes in the data and that can generalize better to new situations.
Right. And so, that's really important because it means that we can create AI systems that are more reliable and that can be used in a wider range of applications.
Exactly.
Yeah.
And I think, another benefit of Neuro-Symbolic AI is that it has the potential to create AI systems that are more capable of higher level reasoning.
Right.
So, as we've been discussing, deep learning systems are very good at, recognizing patterns and making predictions, but they're not very good at reasoning about those patterns or making plans based on those predictions.
Right.
And symbolic reasoning systems are very good at reasoning, but they can have difficulty with the perceptual tasks that deep learning systems are so good at.
Right.
So the hope is that by combining these two approaches, we can create AI systems that can both perceive the world and reason about it.
Yeah. Right. And so, that could lead to the development of AI systems that can solve more complex problems and that can be more helpful to humans.
Exactly.
Yeah. Okay, so let's talk about some of the real-world applications of Neuro-Symbolic AI.
Sure.
We've talked about the benefits in a very general way, but let's get a little bit more specific.
Absolutely.
So where are we actually seeing this approach being used today?
Yeah, so I think one of the most promising areas for Neuro-Symbolic AI is in natural language processing.
Right.
So, natural language processing is all about trying to get computers to understand human language.
Right.
And that's a very difficult task because human language is very complex and ambiguous.
Yeah, it's full of nuance and idioms and metaphors.
Exactly.
Right.
Yeah.
And so, it's very difficult for computers to understand all of that.
Yeah. And so I think Neuro-Symbolic AI has the potential to make a big difference in natural language processing because it can combine the power of deep learning to learn patterns from data with the power of symbolic reasoning to understand the meaning of those patterns.
Right. And so, some of the specific applications of Neuro-Symbolic AI's natural language processing include things like machine translation.
Right.
So, translating text from one language to another.
Yeah.
Information extraction.
Right.
So extracting information from text, like, the names of people, places, organizations, things like that.
Yeah.
Question answering.
Right.
Right. So, answering questions that are posed in natural language.
Yeah, and I think, another promising area for neurosymbolic AI is in robotics.
Right.
So, robotics is all about trying to get robots to interact with the real world.
Right.
And that's a very difficult task because the real world is very complex and unpredictable.
Yeah, it's full of obstacles and noise and other agents.
Oh.
Right.
Yeah.
And so it's very difficult for robots to navigate the real world and to perform tasks in the real world.
Yeah, and so I think neurosymbolic AI has the potential to make a big difference in robotics because it can combine the power of deep learning to perceive the world with the power of symbolic reasoning to plan and to make decisions.
Right. And so, some of the specific applications of neurosymbolic AI in robotics include things like navigation.
Right.
Right. So, getting robots to navigate from one place to another.
Yeah.
Manipulation.
Right.
Right. So, getting robots to manipulate objects in the real world.
Yeah.
And human-robot interaction.
Right.
So, getting robots to interact with humans in a natural and intuitive way.
Yeah. And I think, another promising area for neurosymbolic AI is in computer vision.
Right.
So, computer vision is all about trying to get computers to understand images and videos.
Right.
And that's a very difficult task because images and videos are very complex and contain a lot of information.
Yeah, and it's not just about identifying objects in images, right?
Mm-hmm.
It's about understanding the relationships between those objects.
Exactly.
Right.
Yeah.
And understanding the actions that are happening in the image.
Yeah. And so I think neurosymbolic AI has the potential to make a big difference in computer vision because it can combine the power of deep learning to extract features from images with the power of symbolic reasoning to understand the meaning of those features.
Right. And so, some of the specific applications of neurosymbolic AI in computer vision include things like object recognition.
Right.
Right. So, recognizing objects in images.
Yeah.
Scene understanding.
Right.
So understanding the relationships between objects in an image.
Yeah.
And activity recognition.
Right.
So recognizing the actions that are happening in an image or a video.
Yeah. And I think, another promising area for neurosymbolic AI is in healthcare.
Right.
So, healthcare is a very complex domain.
Yeah.
And there's a lot of data in healthcare.
Right.
And so I think neurosymbolic AI has